last week we were going over how stuff moves in and out of the cell and how cells divide, making an exact replication, an exact copy of themselves. So first we went over how does stuff move. So we have a fluid that is found inside the cell. This is just your medical terminology, guys. Intra, inside. So intracellular means inside the cell. Extra, outside. So we have extracellular is outside of the cell. And interstitial, inside, stitial, tissue. Interstitial fluid, which is fluid. Now this is not blood. This is just the fluid. So those are our three terms as far as our fluids are concerned. Here we had a little bit of a review. We had our cations. Tell me what charge a cation is. Positive, because cats make us feel happy. Anion. I kind of remember that because it sounds like onion. And I don't like onions. They make me sad. And electrolytes are any of these molecules that do carry a charge. And why is this important? Well, when we're dealing with our sick and injured patients, we need to make sure that these electrolyte balances are correct. And this is going to influence the type of IV or intravenous fluids that we give them. So how do we, move you zoomers out of the way. Minimize you, minimized. So moving stuff in and out, so we have things like proteins and which are amino acids, hormones, gases, oxygen, carbon dioxide. All of this has to move back and forth through the cell. And so this next part, we have our passive movement, which does not require energy, and active movement, which does. And the energy that we're using is ATP. Someone tell me what ATP stands for. Nice! Adenosine triphosphate. And then we break the bond, releasing energy, converting it into a diphosphate, reattach, break the bond, reattach, break the bond, and that's how we produce the energy needed for this type of movement. Sorry, my allergies have gone crazy with this weather that we did. All right, so the cell membrane may be permeable, and what permeable means is that it can have stuff move back and forth through it. We can have freely permeable, meaning everybody can come in or out. Selectively permeable, where only certain things can come in and out. And then impermeable, which means not allowed to come in and out or at all. We use the red rover, let so-and-so come over to kind of explain our cell membrane. This guy's still gonna get clocked. He's going down. That guy is going down. So our passive transport, not needing energy, we have diffusion, facilitated diffusion, osmosis, and filtration. We'll go through and just review each of these. For our diffusion, this is where we are using the gradient. Remember, the gradient is the difference between the highest and the lowest concentration. Think of the slide. The greater the difference, the faster you're going to go down the slide. So we are moving from high concentration to low concentration. That is said with the gradient. We're just using gravity going down the slide. And some things that can determine the size of the molecule. Well, obviously, the larger the molecule, the more difficult it's going to be, the slower it's going to move. Is it fat soluble? Our cell membranes are phospholipid. Fats move easily through fat. What is the charge? And then, of course, temperature. When we apply heat, it causes things to move faster. So those are 4 factors that can influence the movement by diffusion using the concentration gradient. Is everybody okay with that so far? Good. I'll take your silence as yes. So there's our gradient moving from high to low. I was thinking about you guys. I have those little, I showed them to you in our last Zoom lecture, what are they called for Bath and Body Works? The wallflowers. And I just put in a new smell when I got home yesterday because I was away from my house for the whole 4 days. So I got home and my diffuser had emptied, so I put a new smell in. Oh, Lord. Does anyone have one of these wallflowers or something like it? Okay. Holy smokes, when you put a brand new smell in that you're not used to smelling, it's overpowering. Yeah. I put one in my kitchen and I have another one in my bathroom. I had to unplug the one in my bathroom because it was so strong in my bedroom. It was like cloying. It was like making my eyes water. And it was a nice smell too.
My sister's a scenting consultant. Our house is just...
Oh, Lord, I don't even want to know what your house smells like. But good to know because I do. Myself and my significant other both have Scentsies and we love them.
Yeah, I mean, it always smells good. And we have 7 dogs who would never, well, we have more than 7 dogs, but the amount of animals who would never know.
Right, and they work amazing, but when you put a new smell in that you're not used to smelling, whoo, talk about the high end of the gradient. Oh, Lord. So here's just a picture. Here's our high concentration, and we see it moving slowly throughout, moving towards low concentration. And the other example we gave was the crowd at NRG Stadium after the Texans win a game. I'm gonna make you guys care about things. I'm gonna make you care. Because you just don't.
Miss Huff, diffusion, so it's just going from high to low, right?
Yep. Using the gradient. The gradient is high to low. So we're all inside the stadium. We're pumped up. Texans won. It was a great game. High concentration is inside the stadium. And we're all moving and diffusing to the low concentration parking lot. There's another toots. Doing some toots. This is an actual book, by the way. Yeah. Those are
Maybe Everybody Poops one too.
Oh, Everybody Poops is a great book. Yes, my niece has that one. Facilitated diffusion. Okay, we're still using the gradient moving high to low, but in this case, we need something to help us move. Here we have a helper protein. The reason why we might need a helper is maybe the molecule is so big that it's not going to pass without damaging the cell membrane. So we need just a special little door. We're still moving high to low. We're still using diffusion. Diffusion is always going to mean moving with the gradient, but this time we have a helper to help us do that. Facilitated means to help. I am facilitating you in learning this material. I'm facilitating you in caring about football. Because, oh my goodness, last night I didn't even watch the game because it was going to be far too painful. Denver Broncos, yeah, they didn't have a quarterback. They played without a quarterback. I know none of you care, but the quarterback's kind of the important guy on the team, and they played without one. They got one of their wide receivers to try and play quarterback against New Orleans. Drew Brees. And it was like 36-3. I'm actually shocked they got 3. All right, here's our picture just showing, here's our little molecule moving high to low. And here's our little helper protein helping them down the stairs. Osmosis is the movement of water. We are no longer using gradients. Okay, gradient is only for diffusion. Only for diffusion. Osmosis is where we're going to dilute out. So now I have a very high concentration. Maybe I put salt in some water and it's very, very highly concentrated. What do I need to do to dilute out that salt water? Add more water. That's exactly what we're talking about here with osmosis. So don't get hung up on the gradient. Gradient from high to low is only movement when we're talking about diffusion. That's it, only diffusion. Nothing else is specific for that high to low. And in this case, we're not moving molecules, we're moving the fluid. Oh, I still didn't change that. I need to note to self. Change this. So this is just some terminology. Hypo and hypertonic. Hypo and hyper are specifically referring to the outside of the cell. Hypo, the outside of the cell is less concentrated than the inside, where the inside is more concentrated than the outside. Exact same thing I just said, just opposite. Hyper, the outside of the cell is more concentrated, the inside of the cell is less concentrated. We did our example of our gummy bears and the the clear adult beverages. And then ISO means the same. So that's optimally what we're trying to achieve, is that the concentrations are the same on the inside as well as the outside. The difference is called the oncotic pressure and the interstitial fluid, which is the fluid inside the tissue. So the difference between between the blood and the tissue is called oncotic. And that will promote the movement of fluid. Again, we're just talking about movement of stuff. The oncotic pressure will promote fluid either moving in or out of the tissues. This could be where you're on a long car ride or a long plane ride and your feet swell up. That's because you've had fluid move into the tissue, causing swelling of the tissue. You get the big swollen ankles. It's also in excess called edema. You may have heard that word from medical terminology. Edema is where you get so much fluid that's accumulated in the tissue that if you take your thumb and push it into the tissue, your thumbprint will stay. Kind of like when you're all at the grocery. We've all done this. You're at the grocery in the meat aisle, and you're looking at the meat, and what do? You poke it. Why do we all do that? That's so weird. But we do. We poke it, and then it leaves a little mark that eventually fades away. That's very similar to what you would see with excess of fluid moving into the tissue. Filtration is just like our coffee maker. We're using blunt force to push it through. Just like water pushing coffee through the filter of your Mr. Coffee. Being pushed through a membrane, which is like our coffee filter. It's just using the pressure, which is greater on one side than the other. So where the fluid is coming out of the coffee maker, the pressure of the water is very high, and it is using brute force just to push that liquid through the membrane into your coffee cup. Our active processes, this is where we are using ATP.
Question.
Yes.
It's the pressure that you're saying is from your heartbeat that pushes it through on the last one?
One example of what could provide the pressure, yes. That's absolutely one of the things, one of the most common things that would cause the pressure. So some of our molecules may not be able to move passively. They do need energy. Could be because they're not lipid soluble. They're far too big. They're on the wrong side of the gradient. Right? If we have a molecule that's trying to move from low to high, now I'm trying to, instead of going from the building to the parking lot, I'm going against the crowd. It's going to take some energy. And so now we're looking at our active movements. We have some things that can be moving in the same direction, sim, meaning together, or against, anti. So this is just referring to the movement of the molecules. We have things moving into the cell and things moving out of the cell. Endocytosis is stuff moving in. Exocytosis is stuff moving out. Here with endocytosis, we had phagio, which means it is taking in, just like waka waka waka, taking in solid molecules, so we're eating. Pino, drinking. And then receptor mediated was our lock and key. Exocytosis is just the reversal. We may be getting rid of proteins that we've made or toxins or waste, stuff we got to get out of the cell. There we go. So there's our phagocytosis. I love this picture. This is where our cell is engulfing solid materials, eating. Oh Lord, did we all eat this week? Holy smokes. I never see another piece of turkey again in my life. Oh my God. Come Saturday, I was just like, no, please. I just want a juicy hamburger. I want something other than turkey. We had turkey hash and turkey salad sandwiches and turkey soup and turkey dumplings. And I'm done. I'm done with turkey. It was delicious, don't get me wrong, but still. Speaking of turkey, I don't know, because it has nothing to do with turkey. Did anybody watch the dog show?
Yeah.
What group won? The hound group. So I will be posting, I gotta go in and see who chose the right groups. And I will let you know, and I'll be adding some extra points onto some tests on tomorrow after you've taken your test. I was really pulling for the toy. Really pulling for that toy. That little, what was it, a little Affenspencer, was owned by our very own royal family, Mattress Mac. Yeah. That was pretty amazing, and it was an off color,
Yeah.
which was kind of weird. I'd never seen an Affenspencer in that kind of charcoal. I didn't either. I was like, what the hell is that? And they're like, there's the Affenspencer. And I'm like, that's not an Affenspencer. Had a lot of really odd colors. We had a liver Dalmatian, which we've never had before. So it was a great show. I got pumped for the show. It's pretty awesome though, right? Seeing all the breeds that you guys have learned about.
I was one that I get to see the Vernon's. That's my like all-time favorite dog in the world.
The which?
The Vernon's mountain dog.
Oh, so awesome. All right, so there's our phagopinon receptor. Solids, liquids, and specialized proteins, lock and key. Picture. And then exocytosis is where we are just reversing the process. Instead of bringing stuff in, we're now taking stuff out, ejecting it to the extracellular space or the space outside the cell. All right, before we move on, is everybody okay with the movement of stuff in and out of our cells? Any questions, comments, concerns? All right, so now we are gonna go in and just review some mitosis. We have two different ways that cells can reproduce. Meiosis, where we have a contribution of multiple cells making a new unique cell. Reproduction. That's not what we're talking about here. We don't want a new unique cell. We want our liver cell to make other liver cells. And we want those liver cells to know how to behave like liver cells. We're going to be discussing mitosis, making an exact replication of the cell. So we know that the majority of the cell's life is spent in interphase. Interphase, also known as what? Well, it was another name for interphase. The resting
Metabolic.
phase, metabolic phase, preparatory. The cell is either preparing to divide or he's just going about his daily cell life, doing his little daily cell job. So the majority of the cell's life is spent preparing or just working. So it's during this phase that our DNA begins to divide. We're preparing. So the first thing we've got to do is make an exact copy of our DNA. And the way that we do that, the first thing we got to do is take our 2 strands of DNA and break them apart. And helicase is the enzyme that does that. Then what we do is we reassemble the proteins, polymerase, and the polymerase is going to reassemble the 2 strands of DNA. We have the lead strand, which is a continuous creation, and the lagging strand, which is in the opposite direction, and it has to keep bouncing back because of the way that it has to be assembled. Is everybody okay with that? We have 3 distinct subcategories to our interphase. G1, which is known as our growth phase. This is where the cell doubles in size. If we're going to make 2 exact copy cells, we need the first cell to get twice as big to facilitate that, to help with that. We have the synthetic phase. This is where DNA is actively dividing and replicating. And then we have our G2 phase. This is where he's packing a lunch. He's gathering the energy and the nutrients that he's going to need in order to properly divide. So all 3 of these are part of interphase. We're all preparing to actively divide. G1, synthetic, and G2. There's a picture of our dividing DNA, our leading strand and our lagging strand. We had a bunch of those pictures. Picture, picture. This is a great picture. Showing continuous here on our leading, and then here we're having to go the opposite way. So we're creating, then dividing, coming back, creating, bouncing back, creating, bouncing back. And it causes this little stutter, and that's why it's called the lag. Just like your computer gets laggy. Once our DNA has replicated, it turns into this super hypercoiled, still attached to each other. So what I have here is 2 strands of DNA. I have 1 strand here and 1 strand here. And these strands are exact copies of each other. 1, 2 exact copies, but they're super hypercoiled. And now we're going to go ahead and actively divide this cell into 2. We had our PMAT. Remember our PMAT. P stands for prophase. Well, if all of our DNA is contained in the nucleus, what do we got to do? Got to get rid of the nucleus. And so that's what's happening here. The nucleus begins to go away. We have our centrioles, which were from last chapter, start to build our tug of war ropes. They're called spindle fibers. So during prophase, the nuclear envelope goes away and our fibers begin to appear. Disappears. Because right here, these are all of my DNA. Well, I can't split this in half if they're all locked up. I gotta set them free, man. I gotta set them free. So I gotta get rid of this nucleus. Metaphase, metaphase, middle. All of my chromosomes are lined up in the middle. I attach my little tug of war spindle fibers to each side. And now I'm going to get ready to play tug of war. So metaphase, they all line up in the middle. Anaphase is where I pull them apart. Anaphase is going to be my tug of war. Spindle fibers pull each one strand of DNA towards each side of the cell. And then finally we have telophase. And this is where the DNA is now going to be re-enclosed inside its own nucleus, and the cell membranes divide from each other. I do have that video that I showed you, I think I showed that to you last week, of the animation of all of this happening. It's a great animation. If you go back and review it, it'll really, really give you visual learners a couple of extra little things to think about. So there we have a picture. I love this picture. Nuclear envelope disappears. Prophase. Everything lines up in the middle. Metaphase. My spindle fibers start pulling it apart. Anaphase. I have my nucleus up here, and my cell membrane separates the two cells. Telophase. So how do cells know when to stop dividing? We don't want them to be dividing uncontrolled all the time. And that's where we have what's called contact inhibition. Inhibition means to stop. So when I have my cells replicating, and now they're all touching, I have enough cells to fill up this whole room. I have enough Huff cells. And there's a Huff cell touching my chest and my back and my two arms. That tells me stop. Now, as those Huff cells are taken out, they get old, they get damaged, suddenly I have space opening up in the room, and it's that space, that lack of contact, that then tells me start dividing again. Here's just some terminology referring to my RNA. Remember, our RNA is where we are writing down instructions, delivering instructions, and then using those instructions. So the example we gave was getting the recipe from my mom, and I copy it down, transcription. I transcribe the recipe. My codon, which is messenger, I'm going to take that recipe to the grocery store, and I'm going to get all of the ingredients that I need. Translation, I'm going to take the recipe and the ingredients that I now have, and I'm going to make the thing. I'm going to make the pie. Oh Lord, we did have a lot of pie. I made 3 pies, you guys, for 2 people. I know. We're ridiculous people. Now, what happens if something goes wrong? If we don't get an exact copy of our DNA, and now we have an incorrect strand of DNA that is now replicating incorrect strands of DNA. These are known as mutations. Now, we could have a genetic mutation, which is more with meiosis. The blueprint for life is incorrect. Or we could have a mutation as far as mitosis. That would be like cancer, where you have a rogue cell start to divide and create more and more and more rogue cells. So this can happen either during reproduction or after reproduction. And these mutations, like I said, they can be caused by viruses. That's one of the kind of terrifying things about this virus that's going around right now, is it's causing lung cells to mutate. And then your lung cells no longer know how to act like lung cells. Well, that's not good. You kind of need lung cells to know what they're supposed to do. The more lung cells now that are dividing incorrect cells, the more incorrect lung cells you have, the less working lung cells you have, and then you can't live without lung cells. And that's a big problem. Radiation causes the same issue. And that can all cause forms of cancer. And then, of course, we had there's our genetic mutation. This is a an incorrect coding when we get into reproduction. And that was my 5-legged mutant. Miss that dog every day. And
That's the one you
differentiate.
said had the extra little fingers?
Yeah, he had a whole extra leg. Little we called him his chicken wings. This little chicken wing. And then differentiation is just simply saying that different cells act differently. You still know how to do their job, but your liver cell is different from your lung cell. Your liver cell should only be producing liver cells, your lung cells only lung cells. And so even though the process to divide them is the same, the cell job themselves might be different. That's differentiation. Cells have different jobs. Your kidney cell is different than your liver cell. They're dividing the exact same way, but the cell that we end up with has got a different job manual blueprint than what his counterpart had. And that is our review on cell physiology. All right, so, ouch. What questions can I answer for you? Now's the time.
Is our test gonna be on more of us explaining, not explaining, but like knowing how you just showed us osmosis and like the you know, prophase, metaphase and stuff like that, and definitions and stuff?
Yep. Going to be over all of the material from this chapter that we just reviewed. Now, it will be true
I
and
was
false.
asking like the questions, what we need to explain it. That's what I was asking.
Oh, no,
like
it'll be true and false multiple choice
Okay, thank you.
questions. It's true and false multiple choice.
What does ATP stand for exactly?
Adenosine triphosphate, otherwise known as 3 phosphorus molecules bonded together.
So it's an anodic pressure and a hydrostatic pressure. Hydrostatic is like, I'm confused.
All right, so hydrostatic pressure would cause the movement of fluid. Oncotic pressure is the difference in the pressures. So a difference in come on, Doug, get on the wheel. The difference between, like, for example, the pressure in your blood and the pressure in your tissue, the difference between those two would be oncotic. If we start promoting the movement of fluid, that would be the hydrostatic. Oh, look, Yurim has made a Quizlet. Yurim, if you will email me that link, with your permission, I can go ahead and put it on my Moodle for everyone to have access to.
Okay, yeah, I'll email to you right now.
You're amazing.
Thank you.
That is awesome. We all thank you, Yurim. I will link that as soon as I'm finished with class and I get into my email. I will go in and I will link that to my Moodle for you guys to have access to. All right, if there are no other questions, today we're going to get started on tissues. Now, none of the stuff that we're doing from this minute forward will be on your test. Your test is only over the stuff that we just went over. You're doing this. right, so now we're gonna get into our first kind of system. We're now out of the cellular stuff for the most part. We're still gonna have to talk about some cells. But now we're getting into one of our first systems, and this is tissues. We have 4 classifications of different types of tissues. And these classifications are just based on what does it do. We have our epithelial tissue. What is an example of epithelial tissue? Your skin. Your skin is an example of epithelial tissue. In fact, your skin is the largest organ in your body. Skin is considered an organ. And it's going to cover and line stuff. We have connective tissue. Guess what it does? It connects stuff. Give me an example of a form of connective tissue. A tendon. Give me another one. A ligament. Yes, a tendon is connecting muscle to bone. A ligament is connecting a bone to another bone. We have connective tissue under our skin, connecting it to the musculature. So connective tissue just connects stuff. We have our muscle tissue. We actually have 3 different types of muscle. We have our voluntary muscle, which is attached to your skeletal system. Voluntary means you can choose to move it. We have our involuntary muscle, which is making up your organs. We cannot choose to move it. It just has its own movement. And we have the very specialized tissue called cardiac tissue. And it's only found in your heart. And then finally, we have our nervous tissue, which is going to send messages to and from your brain. It sends messages from your brain to your body and from your body to your brain. And it's this constant communication that really allows us to just be alive. Our brain is telling our bodies to make proteins and make hormones and do everything. And then our body sends messages back to our brain. Yeah, we did that just fine, no worries. We're going to follow up with you on that. It just kind of says, yes, the job got done. And that's all because of our nervous tissue. So those are the 4 types of tissue that we'll be discussing in this lecture. I'll give you guys a minute, you're furiously writing. My little note takers. I started the most fabulous new series. Well, it's not new, but it's on, what was it on? Apple TV? It's one that we just found randomly. It's called Mr. Mercedes. Oh, Lord, it is crazy. It is so good. If you have a chance, here's my rec for you guys. If you can find it, we finished the whole first season like yesterday. It was crazy. It is. It's about this guy, no spoilers, but this guy steals a Mercedes. And there's a job fair and he just drives the Mercedes, kills like 16 people. But then he starts 2 years later taunting the retired police officer who'd never cracked the case. And it's crazy. It's so crazy, amazing good. It's so good. I actually started the 2nd season yesterday as well. So we did a season plus in a day and a half. Yeah. The PowerPoint is on my Moodle. Yeah, they're the exact same. This one is just the concentrated one. The one I'm using today is called the testable material. I did not, because it itself was already pretty condensed and shortened. All right, so let's start with our epithelial. Epithelial tissue covers and lines stuff. Now, these cells, they have a robust outer surface, and this outside faces the environment. And it has an inner surface, which faces, obviously, the inside. And these divide, they begin and end other types of tissues. And so a great example of our epithelium is going to be our skin, our mucous membranes, your nose, your mouth, your throat. All of that's going to be created from these epithelial cells. Now, these epithelial cells, depending on where they're located and what their job is, they can have different looks. For example, the epithelial cells of your bladder are going to be a little bit different than the epithelial cells in your skin. Why? Because your bladder has to expand like a balloon. So those cells have to have a greater capacity to change their shape. They're still epithelial cells, they still line and cover stuff, but they do have a little bit of a different look because of their job. Oof. So what do? They act as protection. They keep foreign invaders from getting in your body. They're going to be a filter. Some of them can absorb stuff. In fact, our skin is very absorptive to a degree. Like if you're trying to quit smoking, what do? Put a patch on, and it's being absorbed through your skin. If you put like hydrocortisone cream on an area, it's going to be absorbed through your skin. A fentanyl patch, absorbed through your skin. But our skin's, luckily, based on the species, is pretty selective as to what it absorbs. For example, the amount of water that your skin can absorb is limited. You're sitting in the bathtub, having a lovely hot soak. We don't want you to soak up the water like a little sponge. And so in that case, some does, but to a degree, different substances have different absorptive properties. Epithelial cell plays a role in sensory. In fact, our skin is very sensitive. It lets us examine our environments, hot, cold. We have pain receptors, pleasure receptors, all of that sending environmental information back to my brain. And then we have some cells that will secrete or excrete different substances. For example, sweat glands. Sweat glands are epithelial and they secrete sweat, cooling you down. You have sebaceous glands, which produce oil, which helps to keep our skin nice and conditioned and lubricated. We have some cells that produce mucus, and these cells are known as goblet cells. The way I remember that is I was a humongous fan of the show, some of you may have heard of it, Game of Thrones.
What?
I know, and no, it's not a very well-known show.
No.
It's not very well known. I think it was on HBO. So you may be able to go, I'm obviously joking. Everyone in this room has heard of GOT. Huge fan.
Until the end.
Well, that last season was such a crap show. What a crappy way to end a magnificent series.
Yeah.
I'm still upset about it. Thanks for triggering me. Eric, I'm triggered now. Cersei. Cersei always had what?
Wine.
Glass of wine, a goblet of wine. So now in my brain movie, Cersei is a disgusting person. She was terrible.
Yeah.
She was fabulously terrible.
Yeah.
She was tragically terrible. We all love to hate her. But I just envision her with this goblet. Okay, but now instead of wine, it has phlegm, lung butter, the good chunky kind. You know the kind. You get it and you cough and whoop, it comes up and then you just sit and play with it in your mouth a little bit. Oh, come on, we've all done that. Chew it like gum. Oh, look, I woke everybody up. You do. So now I'm envisioning her with this, lovely, the greeny brown chunks, the kind that, they really are like big globs of snot. And she's just like,
No.
Okay, guess what you're never going to forget ever in your life?
That.
That.
All of them.
So what cells produce mucus? The goblet cell. Because you were drinking it out of a golden goblet. Oh, I'm just so darned evil. All right, so we have some surfaces. These are just the characteristics. We have this word is apical. That's how you say that, apical. And this is going to be facing the body cavity, facing the inside. All this is terminology right now, guys. This is just terminology. So our apical is facing inside the body cavity. Basal is going to be facing outside the connective tissue. Epithelial cells are avascular. Tell me what avascular means. What is the prefix A?
Without.
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 And most are innervated, meaning they do have nerve supply. Well, that makes sense because it's how our body is sending messages to our brains. So we do have nerves, but we do not have active vasculature. So those are kind of our characteristics of our epithelium. We can have a single layer, or we can have multiple layers, and this kind of depends on where they are in your body. For example, you have less epithelial layers in your eyelid than you do on the bottom of your foot. Thank God, because that would be gross. Can you imagine having the same thickness of skin on your eyelid as on your foot? Ew, talk about gross. You guys thought the whole drinking mucus out of a goblet thing was disgusting. No, that would be gross. So different areas of the body are going to have different layers of these cells. Here we have some more terminology, and this terminology is just saying how our cells join together. I have one epithelial cell. I have a second epithelial cell. I kind of need to join them together to make a sheet of cells, right? Think of it like quilting. I have my little quilt patch, and I got to put another quilt patch on, and then another quilt patch, and another quilt patch to make the quilt. These three words, desmosomes, gap, and tight, are just saying how are the quilt patches attached together to make the sheet. Desmosome is super tough, just like Velcro. It does not stretch. It resists stretching. It has pretty high tension. Our skin, our heart, to a degree the uterus. So this is where we can have some shape changing, but that the attachment points are not going to give way. Gap junction is exactly what it sounds like. There's a gap in between. This is going to be found in areas where I have to have stuff easily be able to pass back and forth through between the cells. We're not having movement in and out of the cell. We're moving between the cells. So I need to have a little gap, and so I'm going to have a very loose sewing pattern to leave that little bit of a gap in between. And then a tight junction means just that. Very tightly bound together. This is going to be found in places where I need it to be watertight. For example, your bladder. Yeah. I don't want urine leaking out of my bladder into my abdominal cavity. Just like me, my organs do not like to be soaked in urine. So the tight junctions are going to be just that, watertight, fluid tight, preventing leakage. So desmosome, we have a little bit of give, a little bit of stretch, but it's very tough. It prevents it from ripping apart. Gap junction has a gap, allowing things to pass back and forth through. Tight junction is tight, preventing leakage. Thankfully, 2 of the 3 of these are named exactly what they do. Gap and tight. And so then by reason of deduction, you will automatically know and deduce what desmosome is. Any questions about any of that so far? Everyone's okay so far? Yeah, so far pretty easy, just terminology, mostly terminology. I wonder what kind of animals we're going to get today. I don't even know. I'm so excited. They should be arriving like any minute.
They were down there and I came in. They were barking.
Were they?
Oh, yeah.
New Animal Day is the best day ever. But you guys gotta be, you are gonna be the very first students, other than the ones checking them in, to lay hands on these animals. So we gotta be super duper uber careful during your labs, because we do not have, obviously, behavior testing on these animals. Some animals don't like to be restrained. Some animals don't like other animals. Some animals don't like people. Now, obviously, the shelter that we use, we've been working with them for years. So they're not going to bring us, this incredibly aggressive, eat your face off kind of dog. However, we don't know if there are triggers. So you guys got to be very careful and communicate with each other, with the instructors. And if you have an animal that seems to be getting a little bit triggered, note mentally the trigger and make sure you communicate that so that we can kind of make a notation in the file. So you guys are going to be the ones that are really going to kind of set the foundation for how everybody else is acting around these animals.
Well, working with the animals, do y'all suggest like smooth talking to them, like trying to always like talk to the animal?
Yes and no. So we're gonna try, and the best thing is, number one, everyone needs to be quiet. I know it's very exciting. Adrenaline is just a going. We need everyone to have nice, calm energy, because you all know they pick up on our energies. That's kind of how they communicate with us. So we're all going to be very calm and very quiet. And when you're talking to them, very low, very quiet. They almost feel the vibration rather than hear it. You don't want any loud, jarring noises. You don't want any loud, abrupt. So yeah, talk to them, pet them, interact with them, but always, always being vigilant. The safest place for you to be is having that animal as close to you as possible. So when you're restraining, you get that animal in. Here's my dog. And I put him in I don't know what she calls it. I call it the yoke hold. It's like a cow yoke. So I get, and I'm gonna snuggle this dog's head right into this nook. Like this, body into mine. I now have complete control over this animal. And even if he starts to struggle, he can't come up and bite me. And I can feel if his muscles start to tense, which will be my first indication. No, I'm not asking you, go in and, no. Nice, gentle, but prepared to bring him in if needed. The worst thing you can do with an animal that starts to struggle is let him go. Because now he's free to attack everybody in the room. So very exciting for you guys. And I'm not trying to scare you. 100% I'm not trying to scare you. I'm trying to get you enthused and into a technician's mindset that you guys, the first ones to touch these animals, are going to be able to lay down your observations for everybody else to use. That's pretty cool. Come on, that's pretty cool. I know! Thank you.
I'm excited.
I hope so. All right. So we have the foundation. The way that our epithelial cells kind of work is they build a wall, and the wall has to start from the floor. Right? We build it from the floor up. And then depending on what kind of wall we're building, that'll determine how many bricks up do we use. Do we just use a single layer of bricks? Do we use multiple layer of bricks? But we have to start from this foundation. We call it the basement membrane, also known as the basal lamina. And so depending on where the wall is being built, as I just said, that'll determine the thickness. How many bricks up do we go? Thicknesses could vary. We just discussed, like in our eyelids versus our feet, our elbows versus the inside of our mouth. Because they have very different jobs. My elbow has to withstand stretch over and over and over. The inside of my mouth has to deal with foreign things getting in and maybe scraping and damaging. So even though the cells are the same, the way that they are creating their membranes is a little bit different. So our basement membrane is just the foundation that we're going to build our wall. Some of our epithelial cells have special surfaces. We have some that have what are called microvilli, or small, they're almost like, kind of like our cilia. They're said to have a brush border. And basically what these microvilli do is, we get in here. So I have my intestine, all right, that's my intestine. But if we do a close-up on part of this intestine, we would see that it's actually made up like this, these little folds. And even these folds have folds, and even the cells on these folds have folds. And the idea is to increase the surface area. So that's going to be our brush border, these microvilli. They just increase the surface area. And we see these most commonly in our small intestines, where their job is to absorb nutrients. Some of our epithelial could have keratin, making these specialized areas. Show me an example of a keratinized epithelial structure. Hair, nails, horns, hooves. Those are all specialized areas. Still epithelial cells, but they contain this hardening structure called keratin. All right, so now we're just going to classify what kind of wall are we building? What kind of bricks are we using and how tall are we going to build it? That's all we're going to talk about here. If I'm using a single layer of bricks, I say it is simple. If I use multiple layers of bricks to build my wall, it is going to be stratified. And I think about that because I'm going to build my wall to the stratosphere, out to the sky. So if I use one layer, it is simple. If I use more than one layer, it is stratified. Just terminology, that's all we're talking about. And so here I have the number of bricks I'm going to use. Here I have what shape are the bricks I'm going to use, because we have all different kinds of shapes of bricks. We've got squamous bricks, squished. Squamous means flat and squished cells. Cuboidal. What shape do you think the brick is going to be if I'm having a cuboidal? Cube shaped. How about columnar? Column shaped. So simple and stratified is referring to the number of layers of bricks in my wall. Squamous, cuboidal, and columnar are simply referring to the shape of the brick that I am using. Is everybody okay with that so far? And then of course I have my little specializations, keratinized, ciliated. That's my interpretive ciliated. All right, so the first brick wall we'll talk about is simple squamous. Simple telling us how many layers of bricks am I using? One. And what shape of the brick is in my wall? Flat, squished. Where do we find this single layer of flat, squished cells? Well, it's not creating very much of a barrier, is it? Like I've only got one layer of bricks and they're super squished and I can literally just go like, oh geez, there, I'm over the wall. This area of wall is going to be where we have very easy passage back and forth. Like if I have gases that need to get in and out, they're going to be very fragile. Flat brick, single layer, super fragile and super easy to get through. It's not creating very much of a fence at all. Some specific anatomical, you guys have already heard this, mesothelium. You ever been up like 2 o'clock in the morning Okay, so you all, that's all I had to say. That's all I had to say. If you are a loved one. Some of you are looking at me like you have no idea what I'm talking about. This is a commercial for what condition? Mesothelioma. Well, guess what a mesothelioma is? Oma, tumor of the lining of the chest. And so this mesothelium, single layer, super flat bricks, because in your lungs, in your chest, we need very easy to be able to pass gases, right? Oxygen, carbon dioxide. We don't want to put up a big giant barrier. We don't want there to be a lot of effort to do that. The blood vessels. Again, we need gases to very easily pass out of the blood and into the tissues, and out of the tissues and into the blood. I don't want to put up the Great Wall of China. I want this to be very easy to pass back and forth through. So we're going to use a simple squamous, single layer of very flat, very delicate bricks. Is everybody okay with the brick wall analogy? Fabulous. And time flies when we are having fun, you guys. Holy smokes. We are going to pick it up here.